Okay, so this is the one sample mean. Okay, so for one sample testing, yeah, this should be. So for one sample testing, first you ask yourself, do you know the population standard deviation? So the standard deviation or the variance, right? Because variance equal to standard deviation square. If yes, then we're using t-test. If no, we're just gonna ask if the sample mean is n greater than 30. If yes, then z-test. If no, t-test. So for the case study, this one, the researchers are interested in testing whether the average math score on a new test is gonna be greater than 50. So when I'm reading this question, here are the words that light up for me, and they do not know the population standard deviation. Okay, so no population standard deviation is no. And to study this, they sampled 200 students, that's n, and to take the test. Okay, so what's the population parameter of interest? We want to know the average score. So average math score is the average math score is the thing we are interested to test. And what is the expected value of the population parameter? It is greater than 50. Here, it's greater than 50. This just helps you to understand how to build up the hypothesis. Yeah. And then, okay, so the researchers are interested in, okay, that's still the same thing. And for the specific research question, which is they want to know if it is greater than 50, if the average is greater than 50, we need to do what's the non and alternative. So sometimes you do this, smaller or equal to, because you want this to be the complete set. And describe what a type 1 error and type 2 error would be in this context of the okay, so tips for there's default assumption or no relation. So this one is most of this is H0. That's how you construct it. And the H1 is relationship that you're expecting or interested in testing. So we want to reject this one, and so this one would be true. We are gonna talk about this in the power and error slides, so just follow me here. And so for this one, describing what a type 1 error and type 2 error, this would be in a later slide too. So type 1 error is concluding that the true average is greater than 50 when it's actually equal to 50. So that will be H given H1, and we have H0. That's type 1 error. And so what's type 2 error? It will be concluding that true error is 50 and it's larger than 50. So this one would be H1 given H0. Yeah. Okay, next. So the alpha here is 0.05. Sometimes sometimes you use, like, I remember we're using 0.1, and sometimes even people will use 0.2, but this one is the most common one. Okay, so for this one, still, so which test should we use? So now let's ask the question. They do not know the population, right? And there are 200. So here, do you know the standard deviation? No. Then we're going this way. The sample size greater than 30? Yes. Then we're going this way. So yes, we're doing the z-test. Okay. Now, this is based on the collected data, we have the following result. And what's the test statistic for this test? This is the test statistic. What's the p-value? Here, because we are doing this one-sided, we are gonna choose this one. And what does this lead to? Okay, before I'm going next, how are you gonna choose? Are you gonna, this is one-sided, are you gonna choose this one or this one? This is a trick. So there is a really good tip here, because the alternative, this sign is greater than, then on this final result, you are gonna choose this sign that is greater than. Okay, so you always choose the one has the same sign with the alternative, because this is alternative, right? And then do you reject it or not? Because this one is like 0.000, it's really small, it's smaller than 0.05, and so we reject it. Right. And then what is the 95% confidence interval? So this is the difference between this command and this command. Is I added this one here, so you can see, well, it's basically different. But if you are, somebody is asking you, it's like 98, I don't think people are gonna ask that. But if people are asking 99, then you will just change this to 99, and then this number will be 99. And yes, so how can you how can you interpret it? So we're just gonna say we're 95% confident that the true average is between this. You don't say this one covers the true, because true is always there. So you're gonna say we are 95% confident that the true is between something and something. Yeah. Okay. Next. OneSample t-test. Okay. If you are doing a two-sided test and you are only given the confidence interval, would you reject or fail to reject? So if you're doing a one-sided test, what are you gonna do? So here, confidence intervals are always two-sided. So if you're doing a two-sided test, then confidence interval is, if it includes mu, then you say fail to reject. If it excludes mu, then you reject. For one-sided test, use of confidence interval are not recommended. So if confidence interval include mu, then I don't really know. But if it excludes mu, then reject H naught. Now, still the same question. So question number 7, state the conclusion of the study in the context of the problem. So we would conclude that the average is greater than 50. Now, confidence interval of t-test. So what change would happen to the, to how wide this confidence interval is if something changed, okay? So this is the default one. And see here, if x increase, what's gonna happen to confidence interval? It's gonna stay the same, because this is what we were talking about. If x change, it's just this number. If you're in this, right? So x is here and the confidence interval is this one. Sometimes you change x to probably here, the confidence interval is gonna be the same, but it's just gonna shift from left to right, so it stays the same. And now for the next one, right? For this one, so if t increase, t n minus 1 increase, like this number increase, what's gonna happen to y of the confidence interval? It's gonna increase, right? Because it's x plus or minus something, and if this one increase, and then it's x like minus something and plus something, if this one increase, that means like this one increase, so it's gonna be wider. And then what happened if, oh, right, if the s decrease. So if this one decrease, it's kind of the whole, this part is going to decrease. So this one is going to decrease. And what about if n decrease? If n decrease here, then this whole thing is going to increase. So it's going to increase, yeah. So sample size calculation. To get required sample size for z transforming. So this is a command you're gonna use, and here are everything that this what it means. So of course you can understand that. Okay, yeah, that's it. It's one sample.